Recording in progress.
Okay, so I think we're ready to go. We're already 5 minutes in, so I'd like to get moving. Good morning, everyone. Good afternoon, good evening, depending on where you are. And welcome to the 2025 Asia Pacific Young Scientists Association 3-minute thesis competition semi-final. That takes almost 3 minutes to read. The 3-minute thesis were founded in the University of Queensland in 2008, and today is held around the world in 350 universities across 59 countries. We're proud at UBC to be one of the first universities in North America to host a 3MT competition, and we've been doing it since 2011. AYSA first introduced the 3-minute thesis competition to its activities in 2022. It furthered the tradition of bringing researchers and young professionals together to communicate their work effectively. Each year, we're really pleased to welcome participants from diverse backgrounds and fields, and it really is a truly interdisciplinary celebration. The AYSA itself was launched in October 2020, and it has a mission of helping emerging scholars in forestry, broadly defined, to deepen their knowledge, expand professional networks, and foster collaboration across the Asia-Pacific region, again, broadly defined. The association provides an open platform featuring research seminars, professional development, networking, and academic competitions like this one. You can go to the website if you would like to learn more. This year's competition is organized by the Faculty of Forestry at UBC, the College of Forestry at Northeast Forestry University in China, and Beijing Forestry University in China. This year, there are 6 institutions that have hosted local 3MT competitions between September and October to select their best presenters. We've also received 86 individual online registrations from 21 institutions in 9 countries. Every submission that we receive goes through a thorough evaluation by UBC experts specializing in forestry, ecosystem science, and wood science. It's been a really stiff competition this year, and we found 38 outstanding contestants from 16 institutions in 9 countries who have advanced to today's semi-final. They, or we, or you, represent the very best of research, innovation, and communication in our region. So I'd like to thank all the contestants, organizers, judges, institutional partners, and our global audience. It's your collective passion for science and education that powers the AYSA and makes events like this one possible. Today, we're celebrating your achievements, your collaborations, and your spirit of learning in our Asia-Pacific community. I wish everyone the best of luck, and may your presentations inspire, connect, and ignite new ideas. Thank you for taking part. Over to you, Guan Yu.
Okay, thank you, John. Good morning and good evening, everyone. My name is Guan Yu Wang, Professor and Associate Dean at UBC Faculty of Forestry. On behalf of UBC, it's my great pleasure to welcome you all to the 2025 AYSA 3-minute thesis competition. As just John was mentioned, each year this remarkable event gathering the most talented young scientists, students, and scholars in forestry, ecosystem science, and wood science, and also the related disciplines across the Asia-Pacific region. First, I would like to extend my thanks to our co-organizer, Northeast Forestry University and Beijing Forestry University, and also for the team at UBC. This event will not be possible without your leadership, dedication, and seamless coordination. My sincere appreciation also goes to our supporter across the Asia Pacific University that organized the local competition and sent their best presenter to us. So as John mentioned, University of Cambridge, Canterbury Northwest Agriculture and Forestry University in Shanxi, University of Meghalaya in Indonesia, and University in Nepal, Xinjiang Agriculture University, Northeast Forestry University, and Beijing Forestry University. So your continued engagement strengthens our academic community and create invaluable opportunity for our students to grow, to connect, to shine in the international stage. So I also like to thank our judge today for their contribution to this event. Thank you. And most importantly, I want to congratulate all the participants who has advanced this semi-final round. They have reached this stage is already remarkable achievement. So you are able to distill your research into just 3 minutes, taking not only your deep understanding, but also confidence and ability to communicate the complex idea which clearly impact. You represented the best of our academic community. Today, we will witness the innovative idea, broad question, is inspiring vision for the future. I encourage each of you to join this movement, support each other, and continue to push the boundary of the knowledge. Thank you, and I wish you all the best to all the presenters. Thank you so much. So let's welcome the remark from Duan Liang from Northeast Forestry University.
Can you hear me?
Yes.
Yes. Okay. And dear Dr. Wang, dear Dr. Zhuang, it's very, very glad to see you again. It's our old friend. And last year I participated in this event, and this year we again. It's a great pleasure to co-host the 2025 3-minute thesis competition once again. And on behalf of the College of Forestry at Northeast Forestry University, I would like to extend our warmest welcome and sincere gratitude to all the friends participating in and support this event, especially the Faculty of Forestry of British Columbia. Okay, and looking back to the last year, I also took part in this event, and I was deeply impressed by how the participants, within just 3 minutes, clearly presented their innovative idea for the future of forestry. And the breadth and the depth of their research truly showed the wisdom and passion of a young generation of scientists. And this year, I stand here with even greater joy, and we are delighted to see more outstanding young talents gathered here. I just saw maybe 38 participants in the semi-final. I just saw, and the increased number of students participating in and fully demonstrate the growing appeal and the influence of this competition. And in addition, we very welcome our old friends in China, the College of Forestry at Beijing Forestry University, as a co-organizer this year. And I think the joining of the Beijing Forestry University will bring more diverse perspectives and stronger academic support to this event, and working together to make this platform even broader and more distinctive. And this year, I saw the themes: forest resource management, biodiversity, and ecosystems, and the warm science, bio-based materials, bioproducts, and bioenergy. And closely, island with the core issue in the global forestry and the sustainable development. And I believe that the cutting-edge research and unique insights shared by the students will not serve as a brilliant showcase, and also will spark valuable exchange and the mutual progress in the field of forestry. And now I think the stage is set, and I'm very much looking forward to hear the ideas and experiencing the charm and the passions of the science in the time ahead. And the final, I wish all the participants excellent performance, and I hope you achieved the results you aspire to. And may this competition be a great success. And okay, and thank you everyone. I wish you all the best. Okay.
And now let's invite Jen from Beijing Forestry University.
Distinguished guests, esteemed faculty colleagues, front supervisors, and most importantly, our brilliant young scientists. Good morning or good evening. It's my great privilege on behalf of the College of Forestry and Beijing Forestry University to extend our warmest welcome to you all for our 2025 Asian Pacific Young Scientists Association 3 minutes competition. Here, we are deeply committed to a dual mission, advancing the frontiers of knowledge and cultivating the next generation of scientific leaders. This 3 minutes competition perfectly embodies this mission. It challenges you to do more than just conduct excellent research in the lab or the field. It demands that you refine your ideas, articulate their value, and share your passion with a broad audience. Your research, whether it is in forest ecology, wood science, soil conservation, or landscape gardening, carries the unique signature of your university. You are the emerging voice in a critical global conversation about biodiversity, climate change, and sustainable development. The ability to communicate this work effectively is not a soft skill. It's an essential part of being a scientist in the 21st century. It's how we secure funding, influence policy, and inspire society. So today, we are not just judging presentations. We are witnessing the formation of future science ambassadors. To our competitors, I say, be proud of your work. Speak with clarity, speak with conviction, and help us see the world through the lens of your lens of your discovery. I want to show my sincere thanks to the organizers, judges, and mentors for your guidance and support. To all our participants, I wish you the very best of luck. May your ideas shine brightly. Thank you.
So thank you very much for those presentations. I would like now to have the judges introduce themselves. And the first of those judges is myself. I'm the Dean Emeritus of Forestry at the University of British Columbia. I used to be the Forest Renewal BC Chair in Forest Management, and I am Chair of the Asia Pacific Forestry Education Coordination Mechanism. I'm also Vice Chair of the Board of the APFNet, which is really the parent organization behind this work. And we are delighted that there is so much interest and activity in it. I'll pass it on to the next judge, who is, I believe, Annalyn.
Yeah.
Thank you, John. Hi, everyone. I'm Ana Codilan from the University of the Philippines, Los Baños, and I am a forester by profession, and my expertise is on forest measurements and resource assessment. And I'm happy to be back on 3MT, and I'm delighted to see a very diverse profile of participants this year. So we are all excited to hear about your work, and all the best to our contestants.
Next, we have Zhang Shu.
Hello, everyone. My name is Zhang Shu. I'm an associate professor from College of Forestry, Northeast Forestry University, and glad to see all of you. Thank you.
Next, Dr. Ling Shen.
Hello, so great to see you all. I'm Ling from College of Forestry at Beijing Forestry University. It's my greatest honor to be here as a judge for this wonderful competition. I've been working at Forest Management Department since as a professor since 2012, interested in remote sensing of sustainable forest management. My study area is in the southeast of China, subtropical China, and focused on plantation management, especially Chinese fir. I mainly use very high spatial resolution imagery and LiDAR data so we can cooperate after this, maybe. Cool.
Thank you. And the final judge this evening is Siti.
Okay. Thank you very much, Professor. My name is Siti Hanifah Mahdianti. I'm an assistant professor in the Faculty of Forestry, Universitas Gadjah Mada, Indonesia. And my field of study is about wood science, forest product technology, especially in the non-destructive testing and data science. Good to see you all here, and best of luck of the participants.
Thank you very much to all our judges who are going to spend the next three hours, maybe more, concentrating very intensely on the presentations they're about to hear. I would like to remind all the contestants about the rules. You should be familiar with these by now, but if you're not, it will be a reminder. Firstly, you are allowed one single static PowerPoint slide. No moving graphics on it. It's a static slide. Secondly, you should not be using any additional electronic media, props, or notes. You have a maximum of 3 minutes. When your title slide is displayed, you will be called by name. Once you are ready, the 3-minute countdown will begin. There will be time markers that appear in the bottom right of your screen at 2 minutes, 1 minute, 15 seconds, and 0. You must stop at the 0 time. You will be cut off if you don't, and that could be really devastating if you haven't presented your conclusions. There will be a brief 1-minute break between presentations, which will allow us judges to actually record our notes and make sure that we have sufficient detail to provide you all with feedback at the end of the competition. And finally, I would stress that the decision of the adjudicating panel is final. I'll just run through the judging criteria. We are looking for background and significance, 20 points. We're looking for the research strategy and the findings, which would be 20 points. The conclusions and impact for 20 points. We'll be looking for clarity and appropriateness of language, 20 points. The presentation or the quality of the slide that you show will have 10 points. And we're also looking for your engagement and enthusiasm, which is going to be worth 10 points. I'll just stress that we do know that many of you are in places where internet connections are challenging, including me. The video and sound quality of live virtual event presentations will not be part of the adjudication criteria. So if your internet breaks down halfway through, we will actually make allowance for that and give you another opportunity. I think those are the key points.
Thank you, John.
Okay, I'll pass over to you, June, to take over now.
Thank you, John. Thank you. So everyone, as now that we are here, then we are ready. And please keep your microphone muted. especially if you are not presenting. And again, these competition then the clock will be start ticking. Ready? Go. Chair Wang, please mute your microphone for now. We have the first contestant, Abdulmanem Yamani.
Yeah, that's correct. I'm here.
Perfect. Ready? 3, 2, 1, go.
Every day, millions of people flush or throw away leftover pills, antibiotics, antidepressants, painkillers, thinking they simply disappear. But actually, they don't. They dissolve, flow into wastewater, and begin a hidden journey. Now, here's the twist. Our wastewater treatment plants were never designed to remove these molecules. They can handle bacteria, they can handle nutrients, but not pharmaceuticals. So when the water is released back into the rivers, these invisible pollutants travel downstream, mix into the aquatic food chain, and fish gets exposed to antidepressants and they start behaving differently. Trace of antibiotics encourage resistant bacteria, and that same water, clean, yes, but not purified, can eventually make its way back to us. So among all these pollutants, one chemical stands out, which is carbamazepine, or CBZ for short. It's an anti-epileptic drug so stable, it's found in rivers on every continent. Scientists even call it the marker of pharmaceutical pollution, because if CBZ is there, it means the water is still contaminated. So the cycle repeats from our medicine cabinets, our drains, our rivers, and back to our glasses. So the question is, how do we break this cycle? We need a chemistry that is as smart as the problem. So here my research comes in, using something called electrophoresis process. It's an advanced oxidation technique that literally cleans the water with lightning. So in this setup, electricity flows through 2 electrodes in water. At the cathode, the hydrogen peroxide is generated directly from air bubbles. And with a small amount of iron catalyst, that peroxide transforms into hydroxyl radicals, which is nature's most powerful cleaning agent, by the way. And then those radicals don't just trap or like this, the pollutants, they destroy them, actually. They cut complex drug molecules like CBZ into harmless pieces of carbon dioxide in water. And in my research, you can see in the curve on the slide, the concentration of CBZ falls steadily to nearly 0 just within 1 hour. And that's the power of controlled radical chemistry. Electrophoresis can serve as the final polishing step in treatment plants. Safe, electricity-driven, and chemical efficient. Imagine where communities, advanced treatments ensures every single drop is truly clean, but not just clear. Because clean water is not a luxury, it's a loop, and it's our responsibility to close it. By turning a small spark into a solution, we can finally clean an invisible pollution that we created. Thank you so much.
Thank you. Now let's give the time to the judges. It's never easy to be the first one to go. You did such a great job. Thank you. Are our judges ready to go for the next one?
I'm good.
Thank you.
I'm good.
I'm
Thank
good.
you. Thank you. Professor Chen. Thank you. City.
Yes, please.
Excellent. We're moving on to the next contestant. Akini Malasre Alvitigala.
Yes,
Excuse my pronunciation. You're ready?
yes, I'm ready.
Thank you. 3, 2, 1, go.
Imagine you are in a dark room with just a tiny candle flickering. Now, what if I told you by watching how fast that flame fades, we can learn about the air in the room, even things we can't see, like pollutants or gases. This is the essence of my research on cavity ring-down spectroscopy, a powerful technique that allows us to measure absorption with incredible precision. First of all, why mercury? Why we study mercury? Mercury is a global pollutant and neurotoxic. People even can find mercury in Arctic far away from the emission sites because it travels via atmosphere. So to protect the environment and human health, we must understand the mechanisms and kinetics of the atmospheric mercury redox. So our goal is to gain insights into atmospheric mercury redox chemistry to better understand its biogeochemical cycling. Cavity ring-down spectroscopy, CRDS, the technique that we used in this work, is a highly sensitive optical spectroscopic technique that enables measurement of absolute optical extension by samples that scatter and absorb light. It has been widely used to study gaseous samples which absorb light at specific wavelengths and in turn to determine their mole fractions. In CRDS, a laser pulse is trapped in a highly reflective detection cavity. The intensity of the trapped pulse will decrease by a fixed percentage during each round trip within the cell due to absorption, scattering by the medium within the cell, and the reflectivity losses. The absorption is determined by measuring the difference in a decay time, often called ring down time, for the light trapped in the optical cavity in the presence versus absence of an absorber. We have developed the first multipass CRDS system to quantify the concentrations of mercuric bromide and mercurous bromide radicals. The system uses two lasers, a probe laser to measure the absorption within the cavity, a photolysis laser to break down mercuric bromide into mercurous bromide radicals and further to mercury atoms. Simply, when there is an absorber, the ring-down time decreases, while in its absence, we observe a shorter ring-down time. By applying Beer-Lambert law, the precise measurement of ring-down times corresponding to each level of absorbance allows us to determine the concentrations or absorption cross-sections of our target species. And we obtained the world's first mercurous bromide absorption spectrum. So this study opens the door to a deeper kinetic studies, enabling us to unravel the complex chemical processes with exceptional sensitivity in medical diagnostics, pharmaceutical quality control, air and water quality monitoring, and pollution tracking. Thank you.
Thank you very much. We'll give it some time to the judges to finish their notes. Are our judges ready to go to the next one?
Yes.
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 Thank you. Jan?
I'm good. Yes.
Thank you. We're good. And we will be moving on to the next contestant. Ali Ishan Akmal Shukri. Are you ready?
Hello. Yes.
Perfect. 3, 2, 1, go.
Ladies and gentlemen, when we discuss about nuclear, the scary explosion of Hiroshima, Nagasaki, or Chernobyl suddenly flew into our mind. We are born to believe that nuclear is a destructive power beyond humans' control. But what if I tell you, the power that once used in war can now be used to grow rice? Yes, from atomic bombs to rice field. This is the story of how we are turning the world's most feared technology into a tool of hope for food sustainability. Good morning to everyone. Firstly, join me to unravel the real problems of Malaysian rice. Since 2020, they could only produce 70% of the rice needed daily in Malaysia. The numbers were decreasing annually by 5%. This year, we never know what is left for us. Just like a normal human being, they are less productive when they become weaker. They are factorized by loss of threats around the world, such as soil degradation, as well as pests and diseases. So, here is where my PhD comes in, introducing to you gamma irradiation by cobalt-60 element. Out of 3,000 radioisotopes around the world, gamma irradiation is believed to be the creme de la creme, or best among the best. It has high reliability, faster penetration time, as well as higher energy and accuracy. But wait, you might be wondering, is it similar to the scary atomic bombs? The answer is absolutely no. If it is similar, I would not be here giving this talk to you. To put into perspective, the energy from gamma irradiation is 1 trillion times less than the bombs dropped on Hiroshima. So, how does it work in my project? I use a device known as Gamma Biobeam GM5000. The seeds were irradiated at 350 degrees for 10 minutes only, just enough to nudge the cell activity and induce random mutation. The seeds were then planted into the rice field for 3 generations, following a prominent protocol provided by the International Atomic Energy Agency. As a result, what do we get? Rice with higher yield, good maturity rate, and of course, high resistance against multiple pests and diseases. Most importantly, the seeds were proven to be non-radioactive, classified as non-genetically modified organism, and safe for consumption. As a conclusion, gamma irradiation brings a ray of hope for Malaysian rice. Just like the famous story of the Incredible Hulk, the radiation is here, creating a real-life hero, but in the form of rice. And before I forget, I am not Robert Oppenheimer or a Nobel Prize winner. I am just a common man who felt responsible to save the fate of Malaysian rice. So, let's hold our faith and hand together. Always believe that when there is a will, there is always a way. Thank you.
Thank you, Alif. And we'll give it some time for the judge to finish their notes. Judges, are we ready?
Yes.
Thank you.
Yes, done.
Thank you.
I'm ready.
Thank you.
Yes.
Thank you. And I'm still missing one. Yes. Thank you. So we will go to the next contestant. Andy Nazwa Alua Maharani.
I'm ready.
Perfect. 3, 2, 1, go.
Did you know that Indonesia is the world's second largest source of marine plastic waste? Around 1.29 million tons of plastic enter the ocean every year, breaking down into microplastics, which are tiny particles under 5 millimeters that are hard to remove and can accumulate in marine organisms, including humans, through the food chain. Mangroves, with their dense root systems, can trap these fine particles. This also makes them hotspots for microplastic accumulation, which may threaten organisms living there, especially mollusks as the filter feeders. Nusa Penida, one of Indonesia's marine protected area, is experiencing increasing pressure from tourism. Yet, no study has examined this microplastic contamination in its mangrove ecosystems, which is what motivated me to conduct this research. My study aims to answer two main questions. First, what is the abundance of microplastic in Nusa Penida's mangrove sediments, particularly between the rhizosphere and non-rhizosphere zone? Second, do the benthic mollusks living around mangroves also contain microplastics, and are these similar in type to those found in the sediments? Sediment and mollusk samples will be collected from 2 mangrove zones using 3 1x1 meter quadrants with 3 replications each. The samples will then be prepared in the laboratory through drying, organic matter digestion, density separation, and filtration. Microplastics will be observed under a stereo microscope to determine their morphotypes, whether fibers, fragments, films, pellets, or microbeads, and analyzed using FTIR to identify their polymer types. Through this research, I hope to provide baseline data on microplastic contamination levels in Nusa Penida's mangrove ecosystem and to show how human activities contribute to pollution, even in protected areas. Ultimately, I expect the findings to serve as a scientific basis for better plastic waste management and coastal habitat protection in Indonesia. Thank you very much.
Thank you, Andy. Are the judges ready?
Yes.
Thank you.
Yes.
Thank you.
Yes.
Thank you. Jan?
Yes.
Perfect. So I've got 5 yeses and moving on. Our next contestant, Ao Ying Zhang.
Hello.
Hello, Ao Ying, you're ready?
Yes.
Good. 3, 2, 1, go.
Hello, everyone. It's my great honor to share my research. I'm Aoyin Zhang from Northeast Forestry University, and my topic is lock onto HCM2, an innovative pesticide that precisely combats foodie pest. The Heavy-chikungunya is a global quarantine pest. Its strong adaptability is an important reason for its outbreak. It can feed on 636 kinds of host plants all over the world. That's to see the Heavy-chikungunya is a global foodie pest. Why can it become a foodie? And whether this ability of the foodie can be conquered by human manipulation. Based on this, we analyzed the multi-host adaptation mechanism of the Heavy-chikungunya in terms of the digestive physiology, and a new type of the pesticide has been developed by targeting the K-amylase gene. Through nearly 3 years of the research, we found that among various amylase genes, the HCM2 has the highest expression level of the larvae in medium and low preference host plants. Subsequently, this gene was knocked down by RNA interference technology. We found that it significantly disrupts the adaptability of Heavy-chikungunya to multi-host plants, and even significantly reduce the energy, metabolism, and antioxidant defense level of the larvae. Thirdly, the construct nucleic acid pesticide significantly decreases the body weight and the survival rate of the larvae. The most important thing is that it has non-target biosafety. Finally, the construct nucleic acid pesticide significantly decrease the sensitivity and enhance the sensitivity of the larvae to the plant defense substance, coumarin. Taken together, the HCM2 is a K-amylase gene that mediates the formation of the multiple host plants adaptability of the Heavy-chikungunya. The nucleic acid pesticide targeting HCM2 can green control the Heavy-chikungunya as a multi-host adaptation disruptor and a plant-derived pesticide enhancer. That's all. Thank you very much.
Thank you, Aoyin. All the judges, are we ready to move on?
Yes.
Thank you.
Yes.
Good.
Yes.
Thank you. I have 4 yeses. Ling? Oh, you did. Sorry. The city? Did I miss you?
Yeah, you can.
Ready. Okay. Moving on to the next contestant. Abriba Bano.
Hello, can you hear me?
Yes, we can. Are you ready?
Yes, I'm ready.
Awesome. 3, 2, 1, go.
Hello, everyone. Good morning and good evening. Today, I'm going to present the mechanism of physical and chemical barrier to seeds germination of soap berry. So just take a moment and think about why some seeds germinate on time while some take more time to germinate, even when we give them the same environmental conditions. So the sapindus or the soap berry seeds have exhibit a low germination process. They have both the physical and the chemical dormancy. So on the basis of my objectives is to identify the seeds barrier that causing a low germination in the soap berry and identify the physical, either they are the physical or the chemical, and to study the structure difference of the soft and hard seeds kernel. On the basis of my research method, first of all, I did the seeds bioassay test of soft and hard seed core and seed kernel to identify either the seeds composition is allelopathic or not. Then I did the UPLC analysis to identify the different secondary metabolites that are present inside the seed kernel. So on the basis of the SEM analysis, I study the different layers of the seeds that cause a barrier into the seeds. So according to my results and key findings, it is analyzed that yes, the soft seeds kernel have more allelopathic compounds and it inhibits the germination of cabbage seeds. While the soft seeds kernel also have some secondary metabolites, like they are enriched with some metabolites, especially the flavonoids and alkaloids compounds. While the hard seeds, they have less. On the basis of the SEM analysis, it has analyzed that the seeds, different seed structure have porous layers, like the water can easily penetrate into the seeds and can absorb. But still, the soft seed does not germinate. Why? This is because of some secondary metabolites that are present inside the seeds and cause barrier or cause late barrier to germinate. These chemical metabolites come from the parent plant and also come from the environment. So according to conclusion, little chemicals mainly from the soft seeds kernel cause a dormancy and cause a germination suppressed due to some alkaloids compounds and the flavonoids compounds. So the seeds have no physical barrier, but still the seed does not germinate. This is because of the physiological barrier in which the embryo doesn't potential to grow on time. That's all from my side. Thank you.
Thank you, Ariba. Other judges, are we ready?
Yes.
Yes.
Thanks.
Yes.
Thanks. Thank you. I have 5 yeses. Moving on. The next contestant, Carrie. Carrie Oliva. Are you ready?
Yes, I'm ready.
Perfect. 3, 2, 1, go.
I want you to close your eyes and imagine yourself in a quiet forest. The sunlight passes through the crown of trees, giving warmth to your body. You hear birds singing and a gentle flow of a river nearby, while a cool breeze whistles and brushes gently against your skin. Inhale through your nose, and then exhale. Now, slowly open your eyes. What did you feel? Are you feeling more relaxed? Did you know about 1/3 of people worldwide reported feeling stressed, worried, or angry in 2019, whereas 1 in 4 individuals reported feeling stressed most of the days in a month? In today's fast-paced and technology-driven age, issues like anxiety, depression, and burnout are on the rise. One powerful remedy that has gained attention is forest bathing, or known as Shinrin-yoku in Japan. Forest bathing is simply immersing all your senses in a natural environment. It offers therapeutic benefits for one's emotional and mental well-being. But the question is this practice applicable in a tropical country like the Philippines? What motivates people to do forest bathing? These are the questions that my research wants to answer. I want to examine the intentions of people in engaging in forest bathing. This study centers on one of the ASEAN heritage parks in Southeast Asia, the Mount Makiling Forest Reserve, in an attempt to examine the feasibility and introduction of forest bathing in this site. This is a pioneer study applying the theory of plant behavior as the underlying framework. It aims to introduce this practice in Mount Makiling, setting the groundwork for further development in the Philippines. Theory of plant behavior is a framework for understanding how attitudes, subjective norms, and perceived behavioral control influence intentions and behaviors of individuals. For attitude, when people believe that forest bathing can improve their mental well-being and reduce stress, they're more likely to try it. Meanwhile, the subjective norms is when people see their friends, family, or community members value and practice forest bathing, they tend to do the same. Lastly, when people feel they have the time, access, and ability to join, their intention becomes stronger to participate, and that's perceived behavioral control. So, by linking these three intentions, the theory of plant behavior can examine what drives the visitors of Mount Makiling and possible engagement in forest bathing. I believe by looking at these patterns, the management of Mount Makiling can be guided on how to effectively introduce forest bathing as a new outdoor recreation activity through a holistic and science-based approach. Through this, forest bathing can be promoted as a beneficial practice for people's well-being, community empowerment, and forest conservation. And as an advocate of mental health, let's encourage, support, and motivate people to do forest bathing.
Thank you, Carrie. All judges, how are we doing?
Done.
Yeah, I'm ready.
Ready.
Thank you. 4. I have 4 yeses. Did I miss the last one? Ling or Stiti, did I miss you? Ling or City, are we ready to move on?
Yeah, please.
Thank you. Great. So we are moving on to the next contestant. Cheng Li.
Yes. Yes.
Great. 3, 2, 1, go.
Can you imagine a tree that looks ordinary, the kind you might walk past every day, can actually kill invading insects and protect the entire forest? The tree is the Russian olive, and its enemy, the Asian longhorned beetle, is one of the world's most destructive pests. It has invaded and destroyed broadleaf forests across Asia, Europe, and North America. causing huge economic and ecological losses. But when the Asian longhorn beetle met Russian olive in northwest China, the hunter became the hunted. The female beetle gnaws the oviposition scar on Russian olive to lay her egg. She delivers not only her offspring, but also fluid, bacteria, fungi, and even viruses. Through the receptor near the wound, the tree perceives this influence, especially herbivore-associated molecular patterns. The tree reprograms its metabolism, locate carbon and energy to the wound. Inside those cells, sucrose was broken down by sucrose synthesis, producing UDP glucose. And then it turns into various NDP sugars to build long-chain polysaccharide by glycosyl transferase. Finally, the tree used those polysaccharides as raw materials, secrete a thick, sticky gum. Using CT imaging, we visualized how the egg was suffocated by the gum. By examining thousands of Asian longhorn beetles' oviposition scar on Russian olive, we found that Russian olive kills over 99% Asian longhorn beetle's egg. This discovery reveals a fascinating natural strategy, a dead-end trap tree that high efficiently lure adults and strongly kill their offspring. And what makes it remarkable is that it's self-sustaining, low cost, and adaptable. This shows how nature has its own perfect solution long before we ever invented them. Thank you.
Thank you, Chen Cheng. Judges, are we good to move on?
Yes.
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 Thank you. And I have 4 yeses. I'm waiting on Anna's.
Yes.
Thank you. Moving on to the next contestant, Dunning Lee.
Yes, I'm ready.
Awesome. Ready? 3,
Yes,
2,
yes.
1, go.
Hello, everyone. My name is Daniel Lee from Northeast Forestry University. It is a great honor to be here to today present my project about a demyelination's epigenetic regulates as monolignal biosynthesis. So first one, what is demyelation? Demyelation is a conserved epigenetic modification that is important for gene regulation. Plant demyelation differs from that in animals. In plants, DNA methyltransferase target different sequences CG, CHG, and CHH. In recent years, the study of the demyelation in regulating the growth and development of plants and animals has become a key area of research. Wood formation is driven from the cambium, which is produced the fluon and xylem. This process is critical for lignin-based bioenergy productions. However, whether and how demethylation regulates wood formation. To address this question, we first use a laser capture microdissections to collect the three type cells, fluon, cambium, and xylem, and then perform the whole genome bisulfite sequencing and RNA sequencing to further explore whether demethylation affects a gene expression. We overlap the different expression and methylation genes. Among them, we identified two key as monoligonal biosynthesis genes, CALT5H1 and CALT5H2, which is exhibited significant CHH methylations and expression. Because of the CHH methylations is controlled by the RDDM pathway in plants, we next generated the mutants and overexpression transgenic of the RDDM components in poplars. In order to observe their effect on as monoligonal biosynthesis, the cross-sections were stained with a Muller reagent, which is indicator of the S-lignin. As shown in the pictures, mutants display a laterite color indicating a reduction of in the S-lignin's depositions. In contrast, overexpression plants display a laterite color indicating a reduction in subnate enrichment. In summary, my research established RDDM as a central epigenetic regulator of S-monoligonal biosynthesis, linking dynamic CHH methylations to lignin production during wood formation. This work highlights the targeting of the RDDM pathway as an approach to engineer wood properties for forestry and bioenergy applications. That's all. Thank you.
Thank you, Janine. Judges, how are we doing?
Ready?
Ready.
Thank you.
I'm good.
Thank you. I have 3 yeses.
Ready to.
Thanks, Ning. Anna, let me know when you're ready.
I'm good, Julie.
Thank you. Moving on to next one. David Tors.
Can you hear me and see me?
Yes, now. Thank you very much. Ready.
Okay.
Good. 3, 2, 1, go.
Hello, everybody. At the top of the poster, you can see the main problem, the increasing trend of wildfires, mostly of human origin, and the limited resource and availability of technical and statistical tools to properly analyze them. Using wildfire records from the National Forest Service of Peru, CERFOR, and from the community themselves, I built a 5 years database covering from 2019 to 2023. This allowed me to identify the burning season as well as the spatial and temporal patterns of these events. The main goal of this methodology was to determine the wildfire hazard level for each community based on the theoretical behavior of fire. To do this, I integrated three key components. The first, the NDVI, or Normalized Difference Vegetation Index, used as an indicator of fuel moisture content. The second, the FWI, or Fire Weather Index, which incorporate temperature, humidity, and wind speed, and a slope, which directly influence fire spread. I developed three scenarios using different weights for each variable, with NDVI having the highest influence in all of them. In the first scenario, the weight for FW and slope were very similar, but the resulting map was too homogeneous. And in the second scenario, increasing the weight of NDVI and FWI helped highlight the areas with higher hazard. And in the third scenario, increasing NDVI even further and reducing slope produced the most representative map, reflecting real field conditions and fire behavior observed in the territory. The statistical validation comparing recorded fires with the hazard categories show a strong correlation. I also conduct a participatory validation with the communities. They identify their own hazard zones, and the similarity with the technical map was very high, reinforcing the accuracy of the model. As a result, September was identified as the most critical month, and the most at-risk communities were prioritized for capacity building and prevention actions. This process validates indigenous knowledge, strengthen community response, and contribute to a 64% reduction in the occurrences and 84% reduction in burned areas in 2024. In conclusion, this methodology proved to be an effective tool for wildlife management and community planning, combining technical knowledge with local wisdom. Thank you.
Thank you, David. Judges, how are we doing?
Ready?
Thank you.
Ready.
Thank you. Is it from City?
Yes.
Thanks. Link and John.
I'm ready.
Thank you. So I have 5 yeses. Let's move on to the next contestant. De Kai Meng.
Yeah, I'm ready.
Awesome. 3, 2, 1, go.
Hello, everyone. I'm really excited to share my project with you. A forest tree produces materials and energy. So how does the wood development? Let's look inside a tree. It is composed of various cell types, and the cambium cell is in the middle. It's very interesting. It can also to self-renew and both to produce the xylem inside and phloem outside to increase the stem diameter and form wood. So we all know that the development of cell is closely related to gene. So which gene controls the cambium development? The main goal of our project is to identify this gene. So we hypothesize that such genes are specially expressed in the cambium. To test this idea, we use a laser. We use laser cut the cambium, the xylem, and the phloem tissues. Through the RNA-seq, we identify 95 TF that are specially expressed in the vesicular cambium. The top rank one is a well-known gene, was 4. And the second is a protein that hasn't been studied yet, so we name it VCS2. Later, we want to know whether the VCS2 would actually affect the cambium activity. The transgene line shows that when we overexpress the gene, the cambium cells layer become decreased. And when we overexpress it, the cambium layer has more layers. Ultimately, through a series of experiments, we get such a model. Under the normal condition, we set to interact with 3 other proteins to remind the balanced cambium activity to get the normal wood. And when the VCS2 is absent, the remaining 3 protein promote stronger cambium development, leading to more wood production. You can see a big wall in the middle. And when VCS2 is overexpressed, the cambium cell only have maybe 2 or 3 layers, and the wood is very small. So finally, we discover that the VCS2 can change the epigenetic level of the wood promoter to influence its expression to control the cambium activity. In summary, we identify 95 genes associated with cambium development, and we get a new gene, VCS2. The VCS2 system can coordinate genetic and epigenetic regulation to maintain the normal cambium development for wood formation. We hope this finding may contribute to improve wood breeding and research. Thank you, everyone.
Thank you, Dilkai.
Sorry, I need water. Okay, please. Thank you.
Just checking on judges. Are we good?
Yep.
Yes, please.
Good.
Thank you. I have 3 goods.
Good.
Thank you. The 4th. John, let me know when you're ready. John, are we good?
No, John. Are you talking to?
John, sorry, John. John, Dr.
Yeah.
Shu. Dr. Shu, do I hear a yes from you? Dr. Shu, I see that you're trying to say something, so I think that your mic probably is on mute right now. I take it as a yes. So we'll move on. Okay, so we'll move on to the next one. So we are good. Next contestant, Doria Galia Procuna Remas. Doria? Do we have Doria on the floor? Second call for Doria Galia Fortuna Roimas from Kestak University in Thailand. Third call, the last call for Doria. Looks like Doria is not on the floor, so we will move on to the next contestant. Frederick Antonio.
Hello.
Hi, Frederick.
Can you hear me?
I can hear you. Do you want to turn
Okay.
on your video as well?
All right.
Thank you. Ready? Count 3, 2, 1, go.
Highly valued tropical hardwoods are being overexploited, prompting stricter regulations on illegal timber trade. Yet, New Zealand continues to rely on imported hardwoods due to limited domestic supply. This dependence is a wake-up call and a reminder that we need to invest in producing high-quality, durable timbers locally. That is why my research comes in. I study Eucalyptus botswana, a promising plantation species that could provide New Zealand with its own source of durable hardwood. But there is a challenge. Its decay resistance is highly variable. To address this, I analyzed the New Zealand dryland forest innovation breeding trial from across the country. 10,000 hardwood cores were collected, stained pink with methyl orange to highlight hardwood zone. Then, using a non-invasive method known as near-infrared spectroscopy, I predicted the chemical extractives that give the wood its durability and color. I then combined these data sets or results representing the genetic background of each tree with fine-scale environmental variables in a spatial model. This unique approach revealed that hardwood traits are not only heritable, but also shaped by microsite conditions. That means we can simultaneously improve hardwood quality through breeding and site selection. The first image on my slide represents the current color variation observed in wild populations planted in diverse sites. Whilst the last image represents the uniformity that we can achieve through targeted breeding and site matching. In the future, breeders will now have more precise tools to select superior trees. Foresters will know the best environments to grow them, and New Zealand could produce its own high-value hardwood, thereby reducing imports, supporting sustainability, and shaping a greener, more resilient timber industry.
Thank you, Frederick.
Thank you.
Thank you, Frederick.
Thank you.
Checking on the judges. Are we good to move on?
Ready.
I'm good.
Good.
Thank you.
Good.
Thank you. I have 4 goods.
Yes, please proceed.
Awesome. Thank you. Moving on. We have Ganjan Sharma. Ganjan Sharma?
Yes, yeah, I'm there.
Yes, perfect.
Yeah.
Thank you. Are you ready?
Yes.
3, 2, 1, go.
It's a hot summer afternoon in your city, and you're walking down the street sweating. Suddenly, you step under the canopy of tall plane trees, and the air cools instantly. That moment of relief, that's an ecosystem service. One of the many benefits urban trees provide every day, including cooling the air, filtering pollution, and capturing stormwater. But how do we measure these benefits? We can't walk around with thermometers and flood gauges for every tree. But what we can do is measure the shape, size, and type of each tree to uncover these benefits. Currently, this is done the old-fashioned way. Surveyors walk from tree to tree with tapes and clipboards, manually measuring every tree. Now multiply that by tens of thousands of trees across the city, and you've got a cumbersome job that's slow and costly. My research aims at replacing tape with tech-to-model tree benefits. What if we could measure every tree in the city without even leaving the office? That's exactly what I'm trying to do. I'm mapping the structure of the urban forest from the sky using laser scanning, a technology that sends out laser pulses to capture trees in 3 dimensions. I started with data from airborne laser scanners. Using that, I could accurately measure the height and width of tree crowns across various parks in Christchurch. But airplanes can't see through dense canopies. That's where drones come in. Flying closer to the treetops, they revealed canopy depth and gaps, allowing me to precisely estimate the shape of tree crowns. But shape and size aren't enough. To understand what a tree does for the city, we also need to know what kind of a tree it is. So I'm now using multispectral cameras mounted on drones. These cameras see beyond human vision to identify species based on how each tree uniquely reflects light. By combining all these tools, I'm creating a digital tree inventory. I will then feed this data into computer models that will tell us how much each tree contributes to temperature regulation, air purification, stormwater reduction, while also adding a dollar value to each of these benefits. So this isn't just about replacing fieldwork. My research gives cities the tools to make smarter decisions about their green spaces. By understanding our trees better, we can manage them well and ensure that their benefits are fairly distributed across all communities and neighborhoods. Because ultimately, it's not just about counting trees, but making every tree count. Thank you.
Thank you, Kanyan. Checking on with the judges. Are we
Ready.
good? Thank you.
Ready.
Thank you.
Ready?
Thank you. I have 4 readies.
I'm ready.
Thank you.
It's ready to go.
Thank you. 5. Moving on to the next one. This is the last one before we take a 5 minutes break. Invite to the floor He Huang.
I'm ready.
Perfect. 3, 2, 1, go.
Hello, everyone. My name is Huang He. I'm a PhD student at Northeast Forestry University. It's my honor to speak here, and I'm very glad to share my research with you. The title of my research is Organic Nitrogen Benefits, Confer Seedlings Growth, and Drought Stress. In the period of 1950 to 2009, drought stress in Northeast China happened more frequently and lasted longer, and conifer is the main tree species in this area. As we know, drought stress destroys plant photosynthesis, leading to carbon starvation. But compared to inorganic nitrogen, such as nitrate and ammonium, plants, especially conifers, can uptake organic nitrogen with carbon bonus, because plants can uptake both carbon and nitrogen during this process. This helps to reduce the plant's consumption of its own carbohydrate. So I propose 2 scientific questions. Firstly, in drought stress, do conifer seedlings change their nitrogen preference? Secondly, in drought stress, does organic nitrogen benefit conifer seedlings growth more than inorganic nitrogen? To answer these 2 questions, I choose 2-year-old green pine seedlings, because green pine is a valuable conifer in Northeast China and is more sensitive to drought stress. Green pine seedlings can uptake both organic nitrogen and inorganic nitrogen. I treated seedlings with 3 drought levels and applied 3 nitrogen forms. Seedlings with no nitrogen application were used as control. I used isotopic labeling experiment to test the nitrogen preferences among different treatment seedlings, and I also assessed the seedlings growth by measuring the biomass of each organ. In my research, I found an interesting result. In well water conditions, green pine seedlings preferred to ammonium nitrogen, but as drought level increased, seedlings preferred to organic nitrogen. This is just like me. When I'm healthy, I prefer to eat rice, but when I have a flu, I prefer to eat noodles. In addition, drought stress significantly decreased the biomass accumulation of green pine seedlings. But in severe drought, organic nitrogen was more beneficial for seedlings growth. At first, I proposed 2 questions. Accordingly, this short research gave 2 conclusions. Firstly, in drought stress, conifer seedlings changed their nitrogen preference from ammonium nitrogen to organic nitrogen. Secondly, in drought stress, organic nitrogen benefited conifer seedling growth more than inorganic nitrogen. This research will provide a new perspective to enhance plant drought tolerance. That's all my report today. Thanks for your attention.
Thank you, He. Well, so that is a first half of our competition. And then we are having this 5 minutes health break. And during the break, I hope that everybody will still keep your microphone on mute. But if you really want to cheer for your friends, your family, you can turn on your mic and shout, "Yay, go! You did such a great job." Take a break, 5 minutes. We'll be back. Hello, for those who just joined us, and we are right on the 5 minutes now. It's 4-minute health break right now. Everybody will be back in 4 minutes.
Hi, Jun. Can you hear me?
Yes, I can. Hi,
Oh, yeah, that's great.
Xiaotong.
Yeah, so can you, so I'm going to check my microphone because they didn't check it.
Yeah, understood. If
Okay,
you want
so
to check your, yeah, perfect.
they can see me
I
right.
can see you and can hear you right.
Yeah, thank you.
Thank you.
Miss you a lot.
Yes, I wish everybody luck today. If anyone is not going away and I would like to sing a live karaoke here, feel free to take the floor. Just joking.
So it's evening there, right? In Vancouver.
It is raining badly right now in Vancouver.
Okay, so it's 6 p.m., 6:30 p.m. there?
It's 6:37.
Okay.
While you're on the break, I would like to promote our final round taking place in a week. We have a social event. It's online. When you're joining, you have the opportunity to meet with people joining the contest as well, to know them and to meet them. As I promoted earlier, please come with your email and come with a fun fact of yourself. Not sure whether you are right next to the computer and can hear me right now. I would like to invite you back to our final competition. Either you are joining the competition or you are being here watching, enjoying, learning. I would like to invite you to come back next week, the same time, because we also have a social event that is online. You will be able to meet with the people from around Asia Pacific area. So come with the email, of course, your name, and also a fun fact of yourself. We will love you to take this opportunity to know more people, get to know the people who are interested in the same subject, same area as you are, create a connection and move forward. Now we are running down into 1 minute before we resume. About 5 minutes is up. Welcome back, everybody. I hope that you're back to your desk next to your computer right now. And we are about to start the second half of the competition. I hope that you have that 5 minutes health break away from the computer. Before we move on, I would like to promote our final round competition. I would like to invite you back if you're not competing, and I would love to have you back here to learn from each other. And also we have a social event towards the end so that you will be able to know each other in the area, in the shared interest in your academic or research. This is a great platform for you to know more people outside of your institution, outside of your country. And then come with your email and a fun fact of yourself. I will send out a round of invitation next week. Before we move on, then I will also want to thank Beijing Forestry University. They are having a satellite branch of the competition out there. I can see everybody sitting in the room out there. Hello, everyone. Thank you so much for being there to support your friends and families. And I would like to see whether our judges are back. Judges?
Ready?
Thank you.
Ready.
I have 3
I'm ready.
readies. Thank you,
Ready.
4. Did I hear from Ling?
Yeah, I'm here, always.
Always. Thank you so much. So we are ready. Moving on to the next contestant. We have Germany and Maca Reyes.
Hi, good evening, good morning.
Good evening and good morning. So when you're ready, I'm going to count 3. 3, 2, 1, go.
Did you know that the smallest island province in the Philippines has been declared a protected area? Not partly, but entirely. That province is Batanes, the northernmost province in the Philippines and the first and only one in the country to receive that kind of status. A bold move for conservation, but one that changed everything. Because when an entire island becomes protected, protection doesn't just cover the land, it can also reshape the lives of the people living within it. And for Batanes, it's the Ibatans. A total of 4 protected laws exist in Batanes: Republic Act 7586, Proclamation Number 335, Republic Act 8991, and the Republic Act 11038. But aside from being a protected area, Batanes is also an ancestral domain through the Indigenous People Rights Act of 1997. Batanes, as a protected area, combined with its unique topography and geographic location, limits the Ibatans' access to vital resources, thereby compromising their basic needs such as food and shelter. My research explores what happens when an entire province becomes protected, from environment to economy and culture to community. Using SWOT framework, I analyzed 7 key assets, namely physical, natural, human, social, cultural, financial, and the legal and political. Through key informant interviews from both local and institutional stakeholders, from 4 of 6 municipalities, namely Basco, Ivana, Uyugan, and Sabtang, I captured not just policies on papers, but the real voices and experiences behind them. The results of this study aim to guide and help the Batanes protected area. But beyond Batanes, it can also serve as a reference point for other protected areas across the Philippines, by helping them craft policies that balance conservation and community well-being. Through its contribution to the project Access and Benefit Sharing Policy Option for the Sustainable Management of Batanes Protected Landscape and Seascapes, my study aims to provide inputs to policy options that just not protect the land but also sustain the lives and heritage of the people who call it home. Because in Batanes, true protection isn't just about saving landscape and seascapes. It is about ensuring equity and harmony between the nature and the people. Thank you very much.
Thank you, Jamani. I'm checking in with the judges. How are we doing?
Ready?
Thank
I'm
you.
good.
Ready.
Thank you.
Ready. I'm ready too.
I'm
you.
ready.
Awesome. 5 readies. Moving on. After the break, everybody's speeding up. Very good. Thank you. Next one, John Louis Educado.
Am I audible?
Thank you. Counting down 3, 2, 1, go.
Good day. I'm Forester John Lu Educado, a graduate student from the University of the Philippines, Los Baños, under the supervision of Dr. Margaret M. Calderon. Batan is located in the northernmost tip of the Philippines, known for its dramatic landscape, quiet open spaces, and strong cultural identity. Its remoteness makes it costly and challenging to reach, with limited flights and weather that often restricts travel. Yet, people continue to visit. Tourists willingly travel the distance for the scenery, the peace that place offer, and the lived heritage of the Ivatan community. From 2016 to 2020, Batanes recorded over 40,000 visitors, demonstrating a strong and sustained demand for ecotourism. This, despite the high travel expenses, particularly plane fares that typically range from 15 to 25,000 pesos, that's about 255 to 425 US dollar per person round trip. A trip to Batanes can be more expensive than an inclusive 3-day tour package in Taiwan or Bangkok. However, this increasing demand also presents a challenge. While tourism creates income, the protected area does not fully capture the true value that visitors place on the experience. This results in limited funding for conservation activities, site maintenance, and support for the communities that protect and sustain the landscape. So my study seeks to address this by understanding what drives tourists to visit Batanes and how much they truly value the experience. To do this, I am using the individual travel cost method to estimate the value of ecotourism by looking at how much visitors spend in both money and time to reach Batanes. I am collecting data from tourists about their travel expenses and experiences, and from this, I will derive a demand curve and estimate the consumer surplus or the added benefit that they receive beyond what they actually spend. This will now reveal the economic value that ecotourism contributes to the province. By identifying the factors influencing travel decision and quantifying the value of their experience, this study can help guide visitor management, investment in tourism facilities, and the development of sustainable financing mechanisms to ensure that ecotourism revenue will directly support conservation and local livelihoods. Ultimately, while the beauty of Batanes may feel priceless, sustaining it requires intentional and informed effort. Recognizing its true value allows us to ensure that its landscapes, culture, and communities continue to thrive today and for generations to come. Thank you.
Thank you, John. Checking in with the judges.
Ready?
Thank you.
Ready.
Ready too.
Thank you. I have
Ready.
3, 4. Or City, did I miss one of you?
Yeah, please.
Okay, thank you, City. Moving on. Next, Joseph Evis.
Hello.
Hi. So counting down 3, 2, 1, go.
When you walk through a plantation forest here in New Zealand, it's easy to be impressed by the tall, straight, uniformed rows of trees. But if you were to stop and take a closer look, you would soon realize that nearly all of these trees belong to just one species, radiata pine. This single species makes up more than 90% of all trees found within New Zealand's plantation forests. They're efficient to grow, efficient to harvest, but means our forest industry relies heavily on just one species. This leaves the industry vulnerable to issues such as pests, diseases, and climate impact. Yet, if you were to look closer within the pines, you would soon realize that there is actually more biodiversity than meets the eye. Across New Zealand, there are many other tree species that have also been planted. There's small pockets of eucalyptus, redwoods, Douglas firs. Sometimes these are planted for timber, sometimes for erosion control, but sometimes they've just been forgotten. These are what we call alternative forest species. But here's our problem. We don't currently know where all of these tree species are. So how do you go about creating a complete inventory for an entire country without having to walk every square meter? This is where my research comes in. I use something called remote sensing. And in its simplest terms, remote sensing is like giving the Earth a checkup from space. Satellites flying overhead capture detailed images of the ground every couple of days, but not just in the colors that me and you can see, in a wide range of different wavelengths, including near infrareds. And what's really neat is that each tree species reflects light in a slightly different way, kind of like a fingerprint. But just like our fingerprints, these differences can be incredibly subtle. Therefore, we turn to machine learning to help us understand and differentiate these differences. This involves training a computer on a vast amount of data to understand and look at these patterns, to help us identify these tree species using satellite data from space. Think of it like teaching your phone to recognize your face, taking repeat measurements over and over until it understands what it's looking at. Only this time, we're using satellites from space. The goal of my PhD is to develop a tool that can automatically detect and classify these alternative forest species using satellite data and machine learning. Remote sensing offers a cost-effective, time-effective, and environmentally friendly way to map and monitor an entire country. Because to truly protect New Zealand's plantation forests, we first need to understand what we have, how much we have, and where it is. Thank you.
Thank you, Joseph. Thank you. Okay, in with the judges.
Ready?
Ready. Ready.
Thank you. Thank you.
Ready?
Thank you. Thanks. So moving on. Our next contestant, Keithana.
Hi, ma'am.
Hello. Hi.
Hi.
You're ready?
Yes.
Counting down 3, 2, 1, go.
Water is life. Yet today, it tells a story of crisis. Rivers, once full of life, now carry the weight of pollution. Around the world, untreated wastewater poisons ecosystem and threatens human health. Conventional treatment plants do exist, but they are costly, energy hungry, and dependent on chemicals. We are cleaning water but harming the planet in this process. So, I ask, can we purify water in such a way that it also heals the earth? Yes, the answer is bamboo, which is strong, fast growing, and endlessly renewable. My research explores how bamboo can replace every major steps of conventional wastewater treatment, creating a process that is sustainable, low cost, and in harmony with nature. It begins with a pre-treatment where the bamboo screen replaces the metal grids, which is renewable, biodegradable, and effective at removing solids. Next is the primary treatment, which uses a bamboo filtration bed layered with pebbles, sands, and bamboo charcoal. Its micropore naturally capture toxin and organic matter, achieving what machines do chemically but naturally. In secondary treatment, life cleans life, where the wastewater flows through the bamboo wetlands, where the roots and microbes work together to break down waste and absorb heavy metals. No electricity, no chemicals, just nature doing what it does its best. Finally, the tertiary treatment, where the bamboo-based biopolishing tanks uses the bamboo membrane and aerogel to remove fine particles and pathogens, producing a clean, safe, and chemical-free water that is ready to run to nature. Beyond purification, bamboo restores because it captures carbon, supports biodiversity, and revitalizing the environment. This is more than a treatment method, it's a philosophy that sustainable solution already exists in nature, waiting for us to listen. When bamboo grows, the earth breathes. When it cleans, the earth heals. With bamboo, we can purify water and our relationship with the planet. Thank you.
Thank you, Kathena.
Thank you, ma'am.
I'm checking in with our judges.
Ready.
Thank you.
Ready.
Thank you.
Ready too.
Thank you. I have 3 readies already. On Anna and City. Take your time.
Ready.
Thank you.
Ready.
Thank you. Moving on. Our next contestant, Kansa Hanom Afifa.
Yes, can you hear me?
Yes, I can, and also can see you.
Okay. Thank you.
Good. Counting down 3, 2, 1, go.
Land cover change is one of the most critical factors influencing water availability in a watershed. Over the past 3 decades, the Upper Opak sub-watershed has faced significant ecological pressure, mainly due to human activities and the eruptions of Mount Merapi. These changes have altered the structure of the landscape, which plays a crucial role in maintaining hydrological connectivity and water balance within the watershed. But this raises a crucial question. When landscape change, how much does it really affect the water we rely on? To answer this question, I conducted a study that aimed to analyze how changes in landscape composition and configuration have influenced water yield from 1990 to 2024 in the Upper Opak sub-watershed. I used Landsat 5, 7, and 8 imageries in Google Earth Engine for 12 analysis years. Land cover was classified into 5 categories, and 10 landscape metrics were calculated using Frogstad software, while annual water yield was estimated using the INVEST model. The influence of landscape characteristic on water yield was then analyzed using stepwise regression in RStudio. The results revealed that between 1990 and 2024, the Upper Opak landscape became more fragmented due to unmanaged land use. Forest dominance decreased, patch shapes became more complex, and connectivity declined. In contrast, built-up areas expanded rapidly, replacing forest and agricultural lands, forming dense urban blocks. Shrubland and barlands became more mixed with other covers. Overall, the total water yield increased by around 21% over the 3 decades, indicating higher runoff, lower retention, and potential hydrological imbalance caused by forest loss and fragmentation. Statistical analysis showed that both landscape composition metrics, such as percent forest cover and landscape diversity, and configuration metrics, like landscape connectivity, agricultural land mixing, and shape complexity of barland and shrubland, significantly influenced annual water yield. The models explained about 87% of the variation at the landscape level and 97% at the class level. These findings highlight that landscape structure is key to sustaining water ecosystem services in tropical watersheds. Therefore, implementing integrated landscape land management through land use diversification, forest restoration, soil and water conservation, and vegetative buffers is recommended to enhance ecological resilience and water regulation. Digital technology and community-based monitoring systems are vital to support adaptive watershed governance in the Upper Opak sub-watershed. Thank you for me.
Thank you, Kansa.
You're welcome.
I'm checking in with the judges.
Ready?
Ready.
Thank you. Thanks.
I'm ready.
Thanks. Awesome. Moving on. Our next contestant, Lan He.
Hello, can you hear me?
Yes, I can also see you really well.
Okay, thank you. I'm
Awesome.
ready.
Thank you. Counting down 3, 2, 1, go.
Hello, teachers and fellow students. Let's talk about the heart of a piano, the resonator, or what we call the strong back assembly. This is where the magic happens, where the string vibration transforms into the music that moves us. For years, we've been fascinated by the piano soundboards, but most of our past research has been a little bit static. We looked at it like a photograph, a frozen moment in time. But the piano is a living, breathing entity. This old approach makes the real drama. So, what is the problem? Well, our star performer, the soundboard, is made of wood, and wood has a mind of its own. It suffers from aging and creep. Think of it like this. Under nearly 20 tons of string tension, the wood slowly sags and changing shapes over decades, like a seasoned storyteller whose voice deepens with age, but not always for the better. Compounding this is a complex pre-stressed stage. Imagine the entire structure is like a tightly woven web of invisible forces, all pulling against each other in a delicate balance from day one. It is incredibly complex and difficult to understand. Now, how do we solve this? Well, we stop taking pictures and start making movies. We're now using linear and transient dynamic simulation. It is our digital time machine. It allows us to simulate the entire life of piano soundboards, from the instant the hammer strikes to how it aged over 50 years, capturing all its quirky, unpredictable behaviors. The key is to master the string-bridge soundboard coupling. This is not just a simple handoff. It is an intimate, dynamic conversation between the string, the bridge, and the soundboards. On this basic, it is also necessary to add a wooden frame and an iron plate, which are required to support the entire string-bridge soundboard system. Our advanced simulation let us listen on this conversation, understanding how the energy flows and where it gets lost. By embracing this dynamic, holistic view, we're not just fixing problems. We're learning to compose the future of piano design, ensuring voice remains vibrant and true for generations. Thank you for listening. Thank you.
Thank you, Lan. Judges, how are we doing?
Ready?
Done.
Thanks.
Ready.
Thanks.
Ready.
Thanks.
Ready?
Awesome. Moving on. Next contestant, Mei Yi Yang.
Yeah, hi everyone. Can you hear me?
Yes, and I can also see you really well. When you're ready,
Okay.
counting down 3, 2, 1, go.
Ladies and gentlemen, imagine walking through a uncountable forest, feeling peaceful and relaxed. But what you may not realize is that deep inside its trunks, a little beetle might return to completely reshape this forest. And this beetle called Seminotus bifasciatus. A little beetle, but a big destroyer. It bursts through the wood of cypress and juniper trees, cutting off the lifelines and leaving behind silent, dying forest. And it has already caused severe ecological and economic damage in Asia. So here's the real question my research tried to figure out. How will this pest spread as climate warms? And can nature itself help us fight back. So as we all know, forests are not just the weather systems, they are living networks. So this past exists depends not only on the environmental situation, but also on the biological relationships with their host plants and their enemies. So ignoring these relationships is like trying to predict a chess game by watching only one piece. So now I'm going to tell you what I've done to predict the suitable area for this past precisely by using both environmental factor and biotic factors. I built 3 models. And the first one called the climate-only model. So of course, I'll only use climate data to predict. And the second one combined the past with their host plant. The third one combined the enemies with the host and the past. So it went one step further. I ran these 3 models and the different climate change scenarios and compared the results, which were really eye-opening. So if we only consider climate, the past range could expand dramatically, and when host plants were included, the risk just grew even higher. However, when added the key natural enemy, something fascinating happened. Large areas once highly suitable for this past became low or moderate risk zones. Nature, in a sense, fought back. So I think my finding reminds us that pest management isn't just about a chemical or a physical way. Actually, biological control could be the most powerful tool for forest protection, and it's also a science-based way to keep forests resilient under the climate change scenarios. So next time you walk under the shade of a pine tree, please remember this marvelous story, one about adaptation, balance, and hope. Thank you.
Thank you, Mei. I'm checking in with the judges.
Ready?
Thanks.
Ready.
Thanks.
Ready?
Thanks. I have 3 readies. I'm waiting on Ling and City.
Ready.
Ready.
Thank you. Moving on. Awesome. Next contestant, Nubria Cabran. Nubria, can you say something in test? You're on mute. Nubria.
Hi.
Hello.
Hello.
Are you ready?
Yes.
Okay, I'm going to count 3, 2, 1, go.
Hi everyone, I'm Rubia from Xinjiang Agricultural University in China. Today I will share a study on heavy metal accumulation in Alms Pumla, focusing on Urumqi, a typical also city in arid northwest China, where the risk of urban heavy metals is rising. We analyzed 7 heavy metals, manganese, nickel, zinc, cadmium, copper, lead, chromium, across 4 functional areas: industrial areas, traffic areas, park areas, residential areas, covering soil, unspumina organs, and total suspended particles, TSP. Industrial areas showed peak metal levels 303 milligrams per kilogram, whereas residential areas displays metal levels, lowest metal levels. Unspumina accumulate most metal in bark and the roots, with Cr enriched in roots, Mn and Pp in bark. For CD, we found a strong across organs and accumulation, and this high correlation R equals 0.9 between its content in plant and the soil. Regression analysis that showed that soil concentration explained 85.9% of heavy metal content in plant, typically in TA. Regression analysis showed residual forms were the major, followed by carbonate exchangeable forms. This study provides a first systematic analysis of multimedia to address critical gaps in understanding organ-specific accumulation. Unspumina play an important role in mitigating heavy metal pollution. Thank you for your attention.
Thank you, Nurbia. I'm checking in with the judges.
Ready?
Ready.
Ready.
Ready?
Thank you. I have 4 readies. Ning, are we good to go? Okay, awesome. Moving on. Qian Huiyu.
Okay, can you hear me?
Yes, I can, and I can also see you clearly.
Okay, I'm ready.
Thank you. Counting down 3, 2, 1, go.
Hello, everyone. Today, I'd like to share with you our recent development, wood, a sustainable wood-based material designed to make buildings more energy efficient. As we know, buildings account for a large share of global energy consumption, and the resulting carbon emissions cause severe environmental challenges. Therefore, improving building energy saving is crucial. Among many strategies, thermal insulation and radiative cooling are considered highly useful. However, traditional insulation or cooling materials often suffer from high energy cost in preparation, poor scalability, or limited mechanical performance. Wood, on the other hand, is abundant, renewable, and has served as a green building material for millennia. In this work, we developed wood from nature wood by simple chemical treatment and ambient drying. Compared with conventional building construction materials, our strategy is low carbon, energy saving, and scalable. After removing lignin and hemicellulose, the wood cell wall becomes highly porous, leading to a very low thermal conductivity. At the same time, wood retains the multi-scale structure of nature wood and gives it a high mechanical strength. This design addresses a long-standing problem of traditional insulation materials, the difficulty of achieving both low thermal conductivity and high mechanical strength. Wood also shows excellent optical performance, with high solar reflectivity and infrared emissivity, allowing passive radiative cooling. Building energy simulations indicate that when wood is put on the roofs and inside walls, it can save about 40% of cooling energy consumption. Moreover, across China, the simulations show significant energy saving potential, especially in the southeastern regions where cooling demand is the highest. In summary, wood represents a sustainable, scalable, and high-performance alternative for future building energy-saving applications. We believe this work provides not only a practical material solution, but also a route toward greener construction. That's all. Thank you.
Thank you, Qianhui. I'm checking in with the judges.
I'm good.
Thanks.
Ready?
Thanks. Thanks.
Ready?
Thanks.
Yeah.
Good. We're moving forward. Next contestant. Ridwan Ayina.
Hello, everybody.
Hello.
Hi.
I'm going to count 3, 2, 1, go.
Today, I will tell you a story about me, you, and our future. Imagine a world where all the energy that we use is from the waste that we throw away every day. This is not science fiction. It is the future that I am working to create for all of us. According to the global energy statistics, the average energy use per person globally is 59 million British thermal units. That is extremely huge, but the question is, where is this energy coming from? Largely from fossil fuel. And this heavy reliance on fossil fuel is expensive and has caused the release of toxic greenhouse gases that are hurting our environment. Therefore, there's a need to transition into renewable energy sources like solar and wind. Right now, the biggest challenge of efficient renewable energy exploration is how to store it. While solar panels and wind turbines have the capability to generate massive amount of energy, bulk of this energy are being wasted without an efficient ways to store them. Even the traditional batteries, like what you have in your cell phone or what you have in your cars, are expensive and they are made from non-renewable material. And this is exactly what my research seeks to address. My work is focused on developing batteries from agricultural waste. I do this by converting this waste into extremely small carbon-based nanomaterials. These nanomaterials are then used to build two parallel plates called electrodes and electrolytes that have the capability to store massive amount of energy. I have collected this waste, I have converted them into carbon-based nanomaterial. I have also built these batteries all in our lab. Interestingly, our result shows that 1 gram, just 1 gram of our material is able to trap 470 farad of energy. To put things into perspective, 470 farad of energy is enough to power your phone for more than 30 days. More importantly, we have also conducted some stability tests by charging and discharging these batteries 10,000 times. And what we notice is after the 10,000 cycle, we still have about 98% capacity retention. This is extremely huge for our future. This idea represents the blueprint for green energy that is sustainable, low cost, and of course, renewable. Ladies and gentlemen, the future that I talked about is here. Thank you.
Thank you, Ridwan. Checking in with the judges.
Ready?
Thank you.
Ready.
Thank you.
Ready.
Thanks.
Ready?
Thanks. I have 4 readies.
Yeah, we ready.
Thank you, Siri. Moving on. Next one. Rizky Kurnia Tori.
Yes, I'm here. I'm ready.
Perfect. Counting down 3, 2, 1, go.
Imagine you have a newborn baby. The skin is soft, delicate, and react to the even smallest change around it. Now picture that baby as an amphibian. Amphibians are just as sensitive. A slight rise in temperatures or a bit pollution, they feel it immediately. But here's the problem. In all around the world, amphibians are non-charismatic species and often ignored. So I ask you to think about this. If something this sensitive is already sounding the alarm, Imagine what's happening to the rest of our ecosystems. This is where my research comes in. I study the bleeding toad or Leptoprine crentata. This species is endemic, critically endangered, and the only protected amphibian in Indonesia, but is still neglected and poorly understood. So through my research, I'm giving this forgotten species a voice, a message from the futures about where our world is heading. To do that, I projected how the bleeding toad habitat might shift under future climate conditions using ecological niche modeling. I ran the model under 3 scenarios using 5 different machine learning algorithms. And here's the result. By the end of this century, suitable habitat for the bleeding toad declined sharply. From the baseline model, we can see a clear decline in high habitat suitability, which decreased 51% in the mitigation scenario and most drastically 70% loss in the business as usual scenario. If we see on the yellow or moderate suitable area, it has a tendency habitat shifting to the lower elevation, and this result is confirmed by previous research on 40 years amphibian shifting in Gunung Gede Pangrango National Park, Indonesia. And this research is lead to one conclusion. Climate change is a serious threat to the bleeding toad habitat. And this research is a wake-up call. Carrying the bleeding toad is like carrying a tiny baby, keeping it safe and giving it a stable home. Just as parents protect their children from the heat and cold, we also have a responsibility to protect the mountains, waters, and forests that sustain this species. The bleeding toad survival is not only a local issue, it is a global one. If we can help to protect these tiny creatures, we are not just a conserved species, we are protecting our planet futures. Thank you.
Thank you very much, Rizky.
You're welcome.
Thank you for trying to stay very focused in presenting.
Yeah.
So I also urge every other people to mute your phone or mute your device so that to provide a quiet environment for the contestants. Thank you. I'm checking in with the judges.
Ready?
Ready.
Thank you. I have 2 readies.
I'm ready.
4.
Ready?
Thank you. 5. Yeah. Again, please keep your device mute so that to provide a quiet environment for all the contestants. Thank you. Moving on to the next one. We have Samadhi Nawalej. Hello.
Hi.
Hi. Counting down. Sorry.
Can you hear me?
Yes, perfectly.
All right. Okay.
Awesome. Counting down. 3, 2, 1, go.
Heavy metal pollution is a global environmental issue that threatens over 200 million people worldwide. It is one of the toughest water problems we have today because these metal ions don't break down. They build up in the environment and inside our bodies, leading to serious health problems. One way scientists have tried to clean this pollution is by using tiny eco-friendly nanoparticles called nano-zero-valent ion. These nanoparticles are fantastic at pulling toxic heavy metals out of water. But the problem is, during synthesis, these nanoparticles tend to clump, losing its cleaning power altogether. So how do we fix it? We provide these iron nanoparticles with a support, something that will help stabilize these nanoparticles while holding them apart long enough until they have reacted with the metal ions. So this is where my research comes in. I use waste bamboo to make something called biochar. Biochar is a carbon-rich material that has a lot of tiny empty spaces inside it. These empty spaces give the iron nanoparticles something to hold on to. How I do this is I first heat the bamboo waste in an oxygen-free environment to get the biochar, mix the biochar with iron salts, and heat it again at a very high temperature to generate the nano-zero-valent ion. Something very interesting happens during this second heating step. The carbon in the biochar rearranges itself around the iron nanoparticles to give graphene shells. These shells act like protective jackets that prevent the iron nanoparticles from clumping. But the real question that I had was, does changing the biochar particle size have any effect? And it turns out it does. When I used smaller biochar particle sizes, I got more ordered graphene shells and more evenly dispersed iron nanoparticles. And I also found that there was a particle size sweet spot, a particle size that gave the best combination of graphene shells and iron dispersion. So by changing something as fundamental as the particle size, I can control how effectively my composite removes heavy metals from water. But what fascinates me the most about my research is how by finding the right structural balance, I can convert something as ordinary as waste into high-functioning, sustainable composites that can help protect our most vital resource, water. Thank you.
Thank you, Samadhi. Checking in with the judges.
Ready?
Thanks.
Ready.
Thanks.
I'm ready.
Thanks.
Ready?
Awesome. Did I see you unmute or City? Yeah. Okay, good. Moving on. Sushma Paldal.
Yeah. Am I audible?
Yes, you are. Clear. Crystal clear. Ready?
Yeah.
Counting down 3, 2, 1, go.
We all live in the community. Let's imagine your community built a forest today. You will be able to collect the forest product in about 5 to 15 years. But what about water regulation, which takes decades and is invisible? This has kept the community forest of Nepal at the crossroad. Once a successful model managed by about 23,000 community forest user groups are now at the verge of abandonment. People see the short-term benefits, but not the long-term hydrological benefits. Many communities are abandoning this forest management, potentially risking the hydrological regulation and water regulation it has built over decades. Now, how to prove these benefits before it's too late? In order to compare the effect of community forest, we need data on hydrological processes. For the context, community forest has been established in Nepal for about 4 decades. And hydrological monitoring has gained attention recently. And to compare the effects of community forest effects, what has it done, we need hydrological data and hydrological processes, which we lack. In that case, hydrological modeling works. I have recreated the scenario, 2 scenarios, which is pre-community forest scenario and post-community forest scenario, to represent the before community forest establishment and after community forest establishment period, which ranges from 1970 to 2020. I have fed the model scenario with the actual land use land cover data, vegetation data, and soil data, keeping the climate data constant, and ran the model. The findings were quite revealing. In my simulations, the simulation showed that the extreme flow has been moderated in the post-community forest scenario. High flows has been reduced and low flows has been maintained over a period of time. Overall, the water yield has been increased due to the increment in the lateral flow and the return flow, and the reduction in the deep aquifer recharge, moderately reducing the evapotranspiration. The major interesting result was that the community forest redirected the surface flow to the subsurface flow, potentially increasing the groundwater recharge. These results are interesting because this shows that community forests manage the water and regulate the water in a way we have not quantified it before. My research suggests to monitor hydrological data and hydrological system in the watershed of Nepal before it's too late, before the community abandon the forest, before the forest management collapse. Yeah, thank you so much. Hello?
Thank you, Sashma.
Yeah.
Thank you. Checking in with our judges.
Ready?
Ready.
Thank you.
I'm ready.
Ready.
Thank you. Awesome. Moving on. Next one, Vimesh, bow down.
Hi.
Hello.
Hello.
Yes, clearly.
Okay, thank you.
Great. Counting down. 3, 2, 1, go.
Imagine living in a timber building, which is safe, strong, and ready to be moved in even after an earthquake. And that's the future I'm working towards. So my research is about cross-laminated timber, a special kind of building material, which is made by gluing timber in alternating direction. This type of materials are not only light in weight, they have enough strength and stiffness, and they are comparable with concrete and steel. However, a small change detail makes a significant impact. That is the connection between CLT. And this connection takes maximum load during earthquake. And if this connection fails, the whole building is in danger. And that's where my research begins. So at first part of my study, I investigated two types of connection system. The first one is surface spline, in which CLT panels were connected to a spline material, keeping it at the surface. And the second one is central spline, in which same spline material was kept at the center. So after assigning earthquake-like loading, it was seen that central spline connection had almost double the strength and stiffness compared to the surface spline. So it shows that only by changing the geometry, we can achieve double the strength and stiffness in CLT connection without adding some extra material. So furthermore, I wanted to investigate how can we improve this central spline connection. So for that, I use different spline material like birch plywood, radiata pine plywood, OSB, and I even changed the orientation of the spline. As we know, timber behaves differently in different orientation. So it was seen that spline whose orientation was perpendicular to the loading had almost 40% less strength and stiffness to the spline orientation was parallel to the loading. And among all tested specimens, birch plywood was the strongest one and provided better stiffness, and it was economical as well. And earthquake does not only test the strength of the building, it tests resilience as well. So I asked, what if CLT connection can be repaired instead of replacing them or rebuilding them after an earthquake? So I came up with simple repairing strategy, adding new fastener in damaged CLT connection. And it was seen that after retesting, it was seen that the repaired CLT connection had almost similar strength and stiffness compared to original one. So I hope from this research, it opens the door in timber engineering, as wood is not only a building material, it is the key to sustainability, resilience, and low carbon future. Thank you.
Thank you, Vimesh. Checking in with the judges.
Ready?
Thank you.
Ready.
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 Thank you.
Ready?
Awesome. Moving on. Next one, Xiaotong Li.
Yeah. Sorry, I'll take my camera. What's wrong with my camera? Sorry. Yeah. Now can you see me now?
Waiting. Still black screen.
Wait a moment. Sorry.
Oh, yeah.
You see me now.
Yes.
Yeah, great to see you again. It's
Yes.
stuck again.
Yeah, it doesn't matter. As long as we could hear you.
Sorry, I want my camera on because, if you see my face, and it will be much better. What's wrong? Stuck?
Yeah, maybe we could just move forward with your audio and you can stay more focused. Although we wish that we could see your face.
Okay, one last try. Okay.
Okay.
What's the problem?
Yeah, I suggest you just go ahead with the presentation.
Okay. I'm sorry.
Yeah, and we trust that you are not reading any notes or anything. Okay?
Definitely not.
Yeah, when you're ready. 3, 2, 1, go.
Okay. Hello, everyone. Have you ever imagined a technology that can turn liquid into complicated solid structures with nothing but light? Well, the good news is that we already have that technology, and it is called DLP 3D printing. The project you wanted will be shaped layer by layer in this 3D printing machine under UV light irradiation. And the key component of this progress is called photoinitiator. In this word, photo means light and initiator means starter. So it's the starter of the whole shaping process. Most of the photoinitiator that we use in the market are molecules based on petroleum. They react really fast, but also toxic at the same time. And the biggest problem is that they may migrate out of the project printed. One typical example of this is TPO. Scientists tried a lot to solve this problem. They grafted different kinds of groups onto the original TPO structures to increase their molecular mass and make them heavier so that they will migrate slower. However, they are still small molecules and they are toxic, not eco-friendly, and difficult to manufacture. Based on those previous works, I proposed a brand new solution. Starting from furfural, it is compound derived from biomass, which is 100% eco-friendly. Then I use solvent thermal technology to treat it, which means I heat it up under high pressure and temperature. And then it will be carbonized and form carbon dots, which is a type of carbon nanomaterial just 10 nanometers in size. Finally, I grafted groups from TPO onto it. Bingo, we got CD-TPO. Those carbon dots acted as heavy tails to grab those photoinitiators tightly and stop their migration immediately. And carbon dots also improved the photoabsorption ability and enhanced the printing quality at the same time. I hope my work will be put into market soon and provide a brand new solution to traditional DLP 3D printing. Thank you.
Thank you, Xiaotong.
I'm sorry for the camera. I don't know what happened.
Yeah, no worries. No worries. We can tell.
Okay.
We can tell you're not reading from Naomi. We can tell.
Yeah. Thank you.
Thanks. Checking in with the judges.
Ready?
Thank you.
Ready?
Thank you.
Ready?
Thanks. I have 4 readies.
You hear me?
Ready.
Yes, awesome. Thank you. 5. Moving on. We have Xing Yi Chen.
Can you hear me or see me?
Yes, I can both see you and hear you. Fine.
Oh, thank you.
Are you ready?
Yes.
Okay. Counting down. 3, 2, 1, go.
Autumn has arrived in northern China. Golden ginkgo leaves drifting round Forbidden City. Red maples blanketing the battling grey wall. But what if that autumn magic started to disappear? That was exactly what happened in Beijing's Western Hills National Forest Park. its signature red-leaf coat industries would die, weakened by pests and disease. Relying on single species made forest's beauty and its ecosystem too fragile. We needed a solution. A tree tough enough for Beijing's dry Rocky Mountains, yet vibrant enough to keep autumn alive and resilient enough to support ecosystem health. Enter Pisidia chinensis, a native gem. It sprouts red leaves in spring, offers cool shade in summer and in autumn. It transforms into a spectrum. Some blaze red, some glow orange, some shine gold. Our bold idea was to create a rainbow mountain in the western hills, planting 3 Pisidia germplasms, red, orange, gold, across different hilltop conditions. This wasn't just for beauty. It was for rethinking forest management to boost biodiversity and resilience. Every tree was carefully placed using the analytic hierarchy process, which involved evaluating site germplasm combinations for both landscape value and ecological adaptability. Then we asked, why do some Pisidia turn vivid red while others soften into orange? Through transcriptomic and metabolomic analysis, we discovered 2 key genes. PCMYB113 acts as a red switch, boosting anthocyanin production for vivid red leaves, while PCL-DOX regulates flavonoid synthesis for orange hues. We also developed a molecular marker system to protect and lead germplasms. Today, over 2,600 Pisidia saplings have taken root. We've used science and technology to bring our best ideas to life on the land itself, where ecological restoration and beauty come together as one. In the coming autumn, the rainbow will flow from foothills to the mountaintops, a vivid reminder that healthy, vibrant forests are a gift for nature and for us. Thank you.
Thank you, Xingyi.
Oh, thank you so much.
Checking in on with the judges.
Ready.
Thank you.
Ready.
Thank you.
Ready. I'm ready too.
Thank you.
Ready.
Awesome. Moving on. We have 7 more for today. Next one, Xingru Zhao.
Can you hear me or see me?
Yes.
Okay.
Clearly. Yep. Counting down. 3, 2, 1, go.
Hello, everyone. Just imagine walking down the street and seeing 2 restaurants. One is a wildly popular restaurant, while the other is rarely visited. Which one would you prefer? Most people would choose for the trending restaurant. The same goes for Asian longhorn beetles. My research focused on the clustering behavior of the Asian longhorn beetles chewing oviposition scars on Russian olive. Russian olive is a dead and trapped tree of Asian longhorn beetles. It attracts the beetles for oviposition and kill their eggs by gum. During our field survey, we observed that these beetles do not attack every Russian olive. They congregate on a single one, while surrounding trees rarely infested. And what's even strange is that The scars on this unfortunate tree are also highly gathered, primarily on 5 to 8-year-old branches, as if hosting a collective gathering. So, what does the Russian olive do? Today, I will reveal the behind-the-scenes truth of this drama from the tree's perspective, drawing on my research into tree talk, volatiles, and immune system plant hormones. The story began when the Russian olive released special volatile to attract Asian longhorn beetles for feeding. After the first beetle died, it posted online that the tree offered plentiful, delicious food and was also ideal for egg laying. After that, the other beetles rushed to join the feast. The guests arrived, but they were a bunch of destroyers. The tree owner swiftly activated its defense system, dominated by plant hormones. However, due to the overwhelming invaders, the tree's limited supply of defenses weakened its immune system, and the most severely damaged part showed a final drop in hormone levels, leading to a vicious cycle. At the meanwhile, the injured tree communicated its damage to the neighbors through volatiles. The neighbors activated its defense system at once to avoid the beetles' attack. And that is the tree talk and immunity battle triggered by the clustering behavior of Asian longhorn beetles on Russian olive. That's all. Thank you.
Thank you, Xinrui. Checking in with the judges.
Ready?
Good.
Ready.
Thank you.
Ready?
Awesome. Moving on. Next one. Xingtao Li.
Okay, can you hear me?
Yes, I can.
Okay, I'm ready.
Great. 3, 2, 1, go.
Where is the most valuable bank in the world? It's not on Wall Street, it's right beneath our feet. The core asset of this bank is soil organic carbon, a key ally against climate change. However, here's a huge problem. Our land is so vast that we have no idea exactly how these treasures are distributed. To make things worse, a silent and elusive thief, soil erosion, is constantly stealing the wealth from this bank. Globally, the thief displaces about 2.7 billion tons of soil organic carbon every year. During this process, about 40% of that carbon is released into atmosphere as carbon dioxide or methane. It's like trying to save money while a leak drains our wells. However, exhausting research pays less attention to this thief, which may lead to inaccurate predictions of the distribution of carbon. So, my research goal is to draw a more accurate asset map for this bank. And to do that, I'm taking the thief into full account. How? I've gathered 8 types of data from 2000 to 2020, such as climate, terrain, land use, and so on. This includes the soil erosion modulus, which measures how much soil is washed away from each square kilometer every year.
These factors all have more or less an impact on the distribution of carbon. Therefore, I've ranked them according to the degree of influence. I've also sought help from a detective called machine learning. This detective is great at finding hidden patterns in big data. It carefully looks at all the evidence, from clues left by nature to traces of human activities, and is helping me uncover the true distribution and fate of soil organic carbon under erosion. From these asset maps, we can predict that the soil organic carbon content is highest in northeastern part and southwestern part of China, lowest in dry regions of northwestern part of China. Moreover, the content in northeastern part has decreased, while that in southwestern part has increased. Tell us where to build defenses against the seas, and where to restore the ecological to lock-in wells. Only by knowing this can we truly protect the treasures beneath our feet. Thank you.
Thank you, Xintao. While we are waiting on the judges, I would like to do one round of call of our contestant, Doria Galia from Kasetsart University from Thailand. Are you here? Doria? Okay, if you're not here, then moving on. Judges, how are we doing?
Ready.
Ready.
Ready. I'm good.
Thank you.
Ready?
Awesome. Thank you. 5. And moving on. Xingyue.
Okay, can you hear me?
Yes, we can.
Okay.
Okay, counting down. 3, 2, 1, go.
Look around this room. The desk, the floor, the beams above us. There's a 50% chance that wouldn't traveled thousands of miles to get here. For decades, China has imported over half of its wood, a strategic vulnerability for a nation with vast lands of its own. But what if the solution isn't just to plant more trees, but to plant smarter ones? My research offers a path forward by acting as a career planner for one of our most promising trees, the Raureenia or black locust. We explored 3 ways to grow it, from root cuttings, from seeds, and from sprouts. Just like people with different backgrounds excel in different professions, these trees from unique origins also develop distinct skill sets. First, we have the bodybuilder, trees from root cuttings. They grow thick and robust, producing the densest, strongest wood, perfectly suited to be load-bearing pillars in construction. Then there is the supermodel, trees from seeds. They grow tall and remarkably straight with impeccable form, making them the ideal choice for fine furniture and decorative panels. Finally, we have the endurance athlete, trees from sprouts. They may start slower, but they develop reliable strength, excellent for general structures that don't require the highest precision. For 14 years, we monitored their growth and tested their wood. The result is very clear. By simply choosing the right region, we can intentionally cultivate a forest for a specialized purpose. This is the essence of precision forestry. This work changes how we see a forest. You see, a forest is no longer just a source of generic wood. It becomes a highly specialized thing where every tree is trained for a more meaningful role. By understanding and leveraging these natural differences, we can build a more self-reliant, sustainable, and secure future for our own country, building it from the ground up with wisdom. Thank you.
Thank you, Xingyue. Thank you. Checking in with the judges.
Ready.
Ready. Thank you.
Ready.
Thanks.
Ready.
Thanks. I have 4 readies.
Ready.
Awesome. 5. Moving on. We have Yilin Liu.
Hello, can you hear me?
Yes, really well. And see you too.
Okay.
Okay. Now counting down. 3, 2, 1, go.
Imagine standing on the Mongolian Plateau's vast grasslands at winter's end. Herders scan the hills for that first wash of grain. In some years, it arrives on time. In dry years, the hills stay brown. And if late summer dries out, the grain fades early. But drought doesn't just dry places, it moves the days on nature's calendar. So my question is simple. When water is missing, how does nature change its schedule? So we analyzed 20 years of satellite images to mark the 2 moments across the Mongolian Plateau each year. The start of spring growth, which is SOS, and the shutdown in autumn, which is called EOS. Then we compared those days with how wet or dry the land was. Here's what we learned. Drought acts in 2 ways. First, the cumulative effect. When the land stays short of water for months through autumn and winter, soils don't refill and plants just don't rebuild reserves. By spring, leaves wait. Green up is late. In some places, like forests and high meadows, the land remembers many months of dryness, almost a year written into the soil. Second, the lagged effect. Sometimes drought strikes right before shutdown. If the last 1 to 2 months of late summer or early autumn turns dry and hot, plants receive a clear, close early signal, and EOS shifts earlier. So in total, drought squeezes the growing season from both ends, later to start and earlier to finish. But different ecosystems can carry this memory differently. Forests and alpine meadows with deeper roots and better water storage can keep a longer record of past dryness. But open steppes and deserts, however, respond fast to whatever water they have right now. Why does this matter? Because timing decides how much life the land can support. Forage for herders, animals, and flowers for pollinators, and the carbon the land can use in storage year. So here's the main takeaway. To predict spring, watch the last 6 to 9 months of water supply. To predict autumn, just watch the last 1 to 2 months. And that helps with grazing plans, drought responses, and better forecasts. So when the rain is late, nature is late. When the rain runs out, nature stops early. To live well in dry land, watch the calendar of water as closely as the calendar on the wall. Thank you.
Thank you, Yilin. Before we move down to the last 3 contestants, I would like to make another call for Doria. Doria Galia Pronchna Romas. Nope. Okay, checking in on the judges. How are we doing?
Ready.
Thank you.
Ready.
Ready.
Thank you.
Ready.
Awesome. Moving on. The next one, Yu Chen.
Hello. I'm
Hello.
ready.
Awesome. Counting down. 3, 2, 1, go.
In dry areas, clean water is right than food. Traditional water tools are either too costly to build or too energy hungry to use. The UN warns by 2025, 1.8 billion people will face absolute water scarcity, and 2/3 of the world will struggle with not enough water. But here's a useful fact. Our atmosphere is like an iron reservoir. The water in it is about equal to the Amazon River's annual flow. That's why atmospheric water harvesting, taking water from the air, has always been a hopeful solution. Yet this technology used to be hard to spread. Common water-absorbing materials often clump together, so they work worse over time. Some other materials need energy-heavy drying, like freeze drying. Then our team found a new way. We make aerogel, and the key material here is cellulose, extracted right from wood. We mix it with silica and use a special approach that lets us dry the aerogels at ambient pressure, which we call ambient dried. To let these aerogels harvest water, we added 2 key parts. First, lithium chloride. It soaks up water really well, whether the air is dry or humid. Second, carbon nanotubes. They act like tiny heaters. When sunlight hits them, they turn light into heat, turning the water the aerogel absorbs into vapor. Then we can condense that vapor into fresh water. We tested this outdoors too. At night, the aerogel takes in moisture from the air. During the day, sunlight makes it release that water and we collect the fresh water. Even when the sun isn't very strong, it still works steadily. This isn't just an incremental improvement, it's a fundamental redesign. By combining natural cellulose with engineered nanomaterials, we've created a system that works in harmony with the environment. It uses the sun's energy, the air's moisture, and materials from sustainable sources. What does this mean for us? For dry areas that don't have much energy, people might one day get clean water with just a piece of this special sponge. Ultimately, we hope this water harvester can reach more dry areas. It will help people solve their drinking water problems and let forests show their full value. We can truly have a green cycle from forests to people's lives. Thank you.
Thank you, Yu. Checking in with the judges. How are we doing?
Ready?
Ready?
Ready.
Awesome. Thank you. Moving on to the last two. Yu Han.
Okay, can you hear me?
Yes, we can.
Okay.
Ready? Counting down. 3,
Yeah.
2, 1, go.
We all know fire. We use it every day for things like cooking, but a fire is more than a household tool. It's also a tool for the land use, what we call preset burning, as an intentional and controlled use of fire to reduce surface fuels and lower the risk of severe wildfires. It has been used widely in some places, Africa, Australia, and Spain. However, it's still uncertain whether similar outcomes occur in China, especially in climate parts of northeast China. To explore this, we conducted a low-intensity preset burning in 2018 in Pinus State Forest of northeast China. And we set up a burn plots alongside unburned control plots. We collect biodiversity, soil physicochemical properties, and biotic data over the first 3 growing seasons after the burn to answer the question, how does plant diversity respond to preset fire? And when we look into biodiversity indices, we found that preset burning reduced the for the 2 standard biodiversity metrics, the channel diversity and the microlife richness, preset burning lower about 50%. And when we look into community accommodation, shrubs increased and dominated the end story, especially Lesbodisa bicola, whose importance value index exceeded 50% over the first year after the fire. This pattern shows that even the preset burning is low intensity, the biodiversity decreased and conservation reshaped. So why did this happen? We use structural equation modeling to examine the drivers and found that soil chemical properties continue to be the main influences and store biodiversity, but the key driver shifted from nitrate to soil organic carbon, which means that soil chemistry probably may be the main influence and store biodiversity, especially nitrogen and soil organic carbon, which may be in turn influence the plant diversity and the accommodation. So, which means that we still have a lot to do if we want to use fire to promote biodiversity and lower the fire risk in China. And there is something interesting that in total we found that 49 species across 24 family and 41 genera in total, but even the Asteraceae family, there were no dominant species, which will account for about 25% and species of R. And if you would like more details, you can scan the QR code to get the full text of our published paper. And I'm Yu Han from Northeast Forestry University. Thank you all. That's all about
Thank
my
you, Yu.
presentation.
Thank you. Thank you, Yu. Thank you. I would like to check with our judges to see how you're doing.
Ready. I'm ready.
I'm ready.
Ready.
Thank you. Perfect. Now moving on to our last contestants. People always say last but not least. Very important one. Yue Zhu.
Hello, can you hear me?
Yes, we can. Okay,
Okay.
counting down. 3,
Okay.
2, 1, go.
Hello, everyone. I'm Yue Zhu from Beijing Forestry University. Today, I want to share a story beneath the bark into the hidden balance of a living forest. Our existence depends on a world we cannot see and on forests that cannot speak. But beneath every tree's calm green canopy, a silent war is raging under the bark. When beetles invade, they march in with an invisible army, microbes. So when longhorn beetle attacks pinus crenensis, they doesn't fight alone. They bring allies that rewrite the forest's rulebook, changing how trees decay, breathe, and even defend themselves. We can all understand that forests rely on a delicate web of microbes to recycle wood and sustain life. So what happens when that web snaps? When beetle invasion shatters the hidden balance that keep trees alive. I compare the fungal diversity between healthy and beetle-infested pines. It's amazing that healthy trees host a vibrant metropolis of fungi, not just mutual benefit ones, but also decomposers that breaks down lignin, cellulose, and hemicellulose, keeping the forest recycling system alive. But when beetles invade, that diversity collapses. The original decomposers fade away, and the pathogenic fungi, the troublemakers, takes over. It's as if the nature's recycling crew has been laid off and replaced by vandals. Secondly, to make sense of this chaos, I tend to combine machine learning models to spot fungal players that act as molecular fingerprints, which signals beetle infestation. Then, through isolation and enzyme assays, I found that wood-degrading fungi such as Trichodoma, Penicillium, and Fusarium, they didn't vanish but were far less abundant in infested pines. This means the beetles aren't just bringing bad company. They are systematically disarming the tree's defense system by silencing its original fungal bodyguards. This microbial shift matters. By tuning into the voice of microbes, we can detect forest stress long before a single needle turns brown. My work turns these fungi into storytellers. By listening to them, by tracking the biomarkers, we can build an early warning system that detects forest stress before the trees cry out. So next time you walk into a pine forest, green, peaceful, and full of life, just remember, underneath the bark lies a fragile living balance, and the microbes are the one to tell the story. Thank you.
Thank you, Yue. While we are waiting for the judges to finish their taking the notes, and I would like to move on to our last slide here to talk about the final competition. So the final competition will take place next Friday evening, and to some of you it's Saturday morning or afternoon. If you haven't yet, I highly encourage you to sign up our final now. As I said earlier during the break, and we will have a social event going on. Although it's online, it's still very fun. So bring your email, come with a fun fact of yourself. No matter you are competing or not, don't forget that, because you want to compete and also you want to meet new people to create your own professional network. Also invite your friends, bring your family to watch you to play and compete here. I would like to check with our judges. Judges, how are we doing?
Ready?
Done.
Done?
Yes, done.
Good.
Awesome. That is a great word, done. Okay, it sounds like our whole competition is done. And how are we doing, judges? You think that how are we doing the whole time today? Almost
Okay.
4 hours.
I was very impressed with the quality of the presentations that we had this evening. They were considerably better than last year on average, and there were really some excellent presentations. It's going to be quite difficult to weed out the weakest.
Thank you, John. Any other judges? Well, how to keep our contestants high and moving forward. Some of them think that, oh boy, I didn't do well. They are quite anxious right now.
Congratulations, everyone. Those were really, really great studies. John is right. It will be very difficult for us to choose. Thank you so much.
It was
And
a
thank
very
you,
good
everyone. Yes.
presentation. Yeah, it was very good presentation, and yeah, I'm very impressed. I hope everyone still going strong. Yeah. Thank you for having me.
Thank you, City. Thank you, Anna. Any
Yes,
words?
Yeah. So impressive. Lots of topic. They have diversified way to talk about their research. Yeah, good.
Thank you, Ling. And John?
Thank you, Yi. Thank you for your host. And I think all participants gave very wonderful speeches. And thank you to all the judges for your efforts. That's all.
Thank you, all the judges. Thank you for all the audience and contestants. You've done the best of your job here. And then please stay tuned for all the contestants, and we will reach out via email about the results. And all the judges, and you will be sending me the results to consolidate, and then we will have discussion afterwards. Thank you so much, everyone. John, do you hand over to you to finish the night or the day?
Okay, just to prove I'm still here. Thank you very much, everyone, and thank you also to the judges. Really great performances, and thank you all for staying over such a long time. We had a lot of presentations because we had a lot of very good people who've reached the semi-finals. The finals that we will have in a week's time or so, on the 21st, it will be a shorter session because obviously we have to reduce the number of people. But I'm really looking forward to it because we always hear how people have improved based on the feedback they've got. So I'm looking forward to next week, and I hope all of you are too.
Thank you so much, John. Thank you. Thank you, everyone, for coming today. Well, stay tuned. Do come back for the finals for networking as well. Thank you. Have a great day, good afternoon, and good night.
Good
night,
Bye from
everyone.
Vancouver.
Bye-bye.
Thank you.
Bye. Have a good
Bye.
day.
Bye-bye.
Bye.
Bye bye.
Bye.